Alright, so this is my video for 1.7 and 2.R.8 dealing with linear inequalities. So we want to go through some of the basics for like how the symbols look for it. We have our inequality symbol instead of an equal sign now. So we want to use greater than or less than. So this one represents greater than. This one represents less than. Okay, so the opening goes towards the bigger number basically. You can also have the inclusion with it, so we can have greater than with the half equal sign underneath it, meaning greater than or equal to. So it can include that number, or it can be greater than that number. Or we can have the other way, less than or equal to. Okay, so the directions are going to be straightforward. There's going to be a process that you'll have to follow to be able to get to your answer. You want to make sure that you are following what it's going to ask for. So it could ask for interval notation, or it could ask for algebraic notation, and then it could make you graph it. So I'm going to do all three with each of our examples. Just know which one it's asking for. So for like number 1, 2z minus 3 is less than or equal to -7. Okay, so these work just like our equation, so you're not going to do much different. You want to solve and get z by itself. There's only one difference with it, really, and we'll see it whenever it comes up. So normal stuff, you keep the sign as you're going down. Add 3 to both sides. 2z is less than -4. Divide by 2. The sign's still going to stay the same. Z is less than -2. Okay, so as you can see, the sign stayed all the way down. The only time it would be different is if this number would have been negative, then we would have to change the sign. Okay, so we'll see that whenever it comes up later. But it doesn't matter that this is negative only if you divide both sides by that negative. So this is what's called algebraic notation. So if it asks for algebraic notation, you would enter this in. Okay. Most of them ask for interval notation, which is showing the whole interval of solutions that we would have. So in order to see the interval notation, to me it's easier to graph it first. So let's graph it on our number line. Let's say zeros here, 1, 2, -2, -1, -2. So we're saying that z is all the numbers less than -2. So we know -2 is here. All the numbers less than that would be going this direction. So to show that, we need to pick what type of barrier we need to have. Well, we need to look at this. If we have just greater than or less than, you're going to end up using parentheses. If you have greater than or equal to or less than or equal to, you're going to have to use brackets. If we have something with infinities, which infinity will come up, so that's what that means, or negative infinity, those should be surrounded by parentheses. Okay, so you'll see those things come up whenever you do it. We definitely want to use or parentheses to show that we are going to have our brackets to show that we're going to have the inclusion with this. So we have a bracket on that -2. We know it's going to point this direction. Now, only the bracket goes for that number, -2. On this side, you're going to have to use a parentheses. So you'll have to click on the one that has bracket parentheses. So it could be more than one. So it doesn't have to just be a bracket. The bracket goes by the number. Since this is going on forever, that's going towards infinity. So negative infinity is over here. Positive infinity is going this way. So we would have a parentheses going towards that negative infinity. Okay, and shading all that's that side forever. So you would drag the arrow all the way to the left. So this is our graph. So when they would ask for the graph answer, that's what you would put. And then last, we want our interval notation. Okay, so for interval notation, you want to use the graph for what you just did. So you're showing the solutions from left to right. So we're coming from negative infinity with this parentheses. So that's how we're going to write it. Parentheses starting at negative infinity, stopping at negative 2. The negative 2 is included because of the underline, so we need to show that there's a bracket there. So this is the interval notation. It's similar to what the graph is. So you could ask for all three. You could ask for interval notation first and then the graph. Just make sure you're doing, I would do all three either way. You're going to have to find the algebraic notation and this, and you'll have to usually find the interval notation. So I would do all three for you, all of the problems. So let's look at some more examples with that. Let's say we have so this would be number 2. Let's say we have negative 3x minus 3 less than or equal to 15. So same process again. We want to solve this like a normal equation. So we have to isolate x, get it by itself. So we need to move 3 onto the other side by adding it. That way it cancels right here. We'd have negative 3x less than or equal to 18. Then same thing. We need to divide out this negative 3 like normal. That would give us this canceling out to just leave x. But now, since both sides divided by negative, we need to flip inequality sign. So this is not going to be less than or equal to anymore. It's going to be greater than or equal to negative 6. 8 divided by negative 3. So this is our algebraic notation. If they ask for that, you would type that in, the whole thing. Then we need to graph it. Let's say we have, we'll start with negative 3, negative 4, negative 5, negative 6. So we have our negative 6 right here. We know we're going to have to use that point, and we need to know the direction we're going to go. Usually it's pointing in the direction. All the numbers bigger than negative 6 are going to be to the right anyway. But if you look at the arrow, sometimes it helps you to show that it's pointing in that direction. But that only applies if x is first. So in this case, we need to use a bracket to show the inclusion. So we want a bracket on that number. And then we'll shade towards infinity. So this is positive infinity over here. Remember, this side's negative infinity. And we'd have a parentheses to show for that infinity. So we would have a parentheses on that side, and you would drag it all the way to infinity. So that's our graph. And then, interval notation. Use the same thing as your graph. So we started at negative 6, ended at infinity. So negative 6, comma to infinity. Bracket around the negative 6, parentheses around the infinity. Okay. So let's look at one more like that. Let's say we have negative 2x plus 4 greater than x minus 5. So remember, you want your variable on one side, your number on the other. So either direction, it doesn't matter. I usually try and keep x on the left side, especially for an inequality. So I'm going to subtract x this way to cancel it, and then subtract 4 the other way to cancel these 4's. Negative 2 and negative 1 is going to be a negative 3x greater than negative 5, and negative 4 is going to be negative 9. Divide by our negative 3. x is now going to be less than, we divide it by a negative on both sides, positive 3. So there's our algebraic notation. We need to graph it. We'd have 0, 1, negative 1, 2, 3, 4. We want all the numbers less than 3. This time there's no line underneath, so we're going to use a parentheses on the 3. And then we're going to shade to the left, pointing towards the left to show that all the numbers to the left are smaller than 3, towards the negative infinity. So then our parentheses always goes around infinity. So our interval notation, so that's our graph, is going to be parentheses negative infinity, close parentheses, positive 3 parentheses. Okay. So all of the examples are pretty much similar to what that is. You need to do all three, just be careful for what it's asking for in the directions.